So the 12th question we have is a variable circle is drawn to cut the x-axis and origin. Locus of the point of intersection of tangents drawn at the point where the line lx plus my plus n equals to 0 cuts the variable circle. So the question wants us to find the locus. So for every question to find the locus, the first thing we do is assume a point P that would be h, k. So now we use the information given in the question to find the equation for h, k, and at the last step we change h, k to x, y. So the first thing to do we have done is to let the point of intersection of tangents be h, k. We know that it's a variable circle which touches the x-axis and the origin. So by making a graph, we see that it passes through the origin at x-axis. It touches. Okay. So let's assume that the circle has a radius r. So if it touches the x-axis at origin, there can be two sides of the. On both the sides of the axis, the circle can be made. If the radius is r, then it could be 0, r or 0, minus r. It doesn't matter where we assume the circle to be. So let us assume that this is the circle with the radius r. So we have the center 0, r and the radius is given by r. So now it is given that the point of tangents drawn at the point where the line cuts the variable circle. So if the line, let's assume this is the line lx plus my plus n equals to 0. This cuts the circle. Therefore, we can say that this is a chord of a circle. And if from this point we form tangents to the circle, we find that from this point, which is P, h, k, we have to find the locus of P. So in the previous question, we also did that. To find the equation of a chord of a circle from a point P, we use the equation of t equals to 0. Again, we review the concept where t is the transformation from s. X square gives x1, y square gives y by 1, x gives x plus x1 by 2, y gives y plus y1 by 2. Where x1 by 1 are the point from where the polar is. From where the pole is. So for this question, we have x1 as h and y1 as k. So to find the equation, let's find the equation of circle first. The equation of circle would be x minus 0 whole square plus y minus r whole square equals to r square. I use the center and the radius formula. Simplify, we get x square plus y square minus 2yr equals to 0. R square will be cancelled. So for this equation of circle, we use t equals 0 to find the equation of the chord from the point P, h, k. By transforming h to t, we get x1 plus y1 minus 2 times y plus y1 by 2 into r equals to 0. Where x1 is h and y1 is k. So the equation becomes xh plus yk minus y plus k into r equals to 0. So this is the equation of chord that we found. It is also given that this is the same equation for this chord. So by comparing both the equations, we get xn plus yn plus n equals to 0. So both these equations 1 and 2 must be the same. For those the two equations to be same, we have that h by n equals to k by m equals to minus y. Let's separate this. So the first equation would become xh plus k minus ry minus ki equals to 0. So we have just wrote the coefficients of y together. Now it becomes h by l equals to k minus r by m equals to minus kr by m. We assume for any sort of equation which have two equals, we assume it to be alpha, lambda. So h would be l lambda, and k minus r would be m lambda, and minus kr equals to n lambda. So we know that in this equation we have only one variable which we have to eliminate, the parameter, that is r. To eliminate r, we would write r equals to minus n by k lambda. Using this in this equation, k minus n by k lambda equals to m lambda. It gives m plus n by k lambda equals to m lambda. We know that lambda equals to h by l. Therefore, the equation would become k plus n by k h by l equals to m h by l. Using LCM, we have k square l plus n into h equals to m k h. Now we have the final equation. Now for finding the locus, locus of the point of intersection of tangents, we replace h by x and k by y. The final equation becomes, let's just simplify that, mkh. Okay, so mx minus mxy plus ly square equals to 0. This is the final equation that we got.